Tiffany Arielle here, and today we are going to continue with our Learn to Code series. So this is the first actual coding video. The last time was just the setup. So if you have not already watched that, I would definitely recommend you go back and check that out. So that way you're able to follow along with everything that I am doing, because the thing about coding is that you're really not going to be able to understand or learn anything if you don't physically do it. So definitely go back and check that out. I'll have it in the cards. So today we are going to be going over a little robot called Karel. So the first thing that I'm going to do is I'm going to kind of go over Karel and like what it can do, what are the different functions and things like that. And then we are going to actually program Karel to, do a little bit of a task. So let me go ahead and start my screen recording, and then we'll continue with the video. All right, so if you see me looking down, it is because I'm looking at my computer. So my face should be small at this point. The computer screen should be the bigger part. So Karel is this little thing. She lives in this world. She looks like this little, robot. If you did the setup video, you've already seen this. She lives in these worlds, which are basically grids. So this one is a rectangle. Sometimes it's a rectangle, sometimes it's a square. There are sometimes walls in the world like this one, and there are, these things called beepers. So this is the world that Karel lives in. So because she lives in this very simple world, there are only so many things that Karel knows how to do. So in this particular case, they wrote some sample program where Karel is just supposed to pick up this beeper. So all Karel does is move, which is walk one step, pick up the beeper, and then move, which is walk some step. So we can go ahead and click on run program, and we see Karel do those three things, and that's the end of the program. So this is just a very simple example. So now I'm going to show you the reference guide. All these links will be in the description box, by the way, so you can open this and follow along. So this is a pretty much complete list of all the things that Karel knows how to do. So that's the reason why we're kind of starting with this, is because it's a very limited set of possibilities. It's pretty easy to kind of reason around what you're trying to do. So basically, in terms of actual commands, there's only 4 things. Karel can move, which is walk one step. She can turn left. She cannot turn right. She can only turn left. She can put down a beeper out of her bag, which was that little diamond shaped thing, or she can pick up a beeper. Those are all the things that Karel knows how to do. So everything that we are going to do in this series is going to be some combination of these 4 commands. This is the main structure of the program, which we already have that filled in our template.py, so we don't really need to go over that. There are notions of conditions. So Karel, there are certain situations you might say, oh, well, we don't want Karel to run into a wall, for example. We don't want her to hurt herself. So we can check if our front is clear. So I might say, if front is clear, move, basically meaning only take a step if there's no wall in front of you, which of course is a good thing. Okay, I can also check if there are beepers present, because there can be errors if I try to pick up a beeper and there's no beeper in the space. Similarly, if I try to put down a beeper and there's no beeper in my bag, I can have an error, so I can check if there are beepers in my bag. Then there are a bunch of other ones. There's like, oh, if left is clear, right is clear, facing whichever direction, front is blocked. These are just the opposite. These ones on the right side are just the opposite of what's in the left side. So if the front is clear, then the front can't be blocked. So if this is true, then this is not true, and vice versa. So I'm not going to go over the rest of those. And then here they're just giving you a bunch of sample structure. You can paint and corner color is. We're not going to be using these functions, but they're here if you want to kind of play around and experiment with this. So with that being said, let's get into the assignment for today. So the goal for today, this is the assignment 1 handout. We are not going to be doing this full assignment. This assignment has multiple parts. We're just going to be doing the first little section of it. So it's telling us to download the started project and import it, which we already downloaded everything in the previous video. So we do need to import it. So let's go ahead and open PyCharm. Okay, and so I have my recent projects, but in case you don't, let's just click on open. I'll just show you guys how to do this. And I put it under my documents, under Karel, and it's this Stanford Karel master. So I'm just gonna open that. Okay, and we see the template.py that we had before, and we see the test.py. So before we get started, we're just gonna go ahead and run test.py again, just to make sure that our setup is still good. So actually, let me show you what I did. So here, I'm gonna do it the full way. So we go to run, we go to run again, and then we select test and it opens. Now, if you've already run this, you'll see it here. It'll say test and you can just click on this play button. So that's the other option. And then we'll run program. We see Karel is spinning in a circle as she did before. So that is good. Our setup is still working fine. So let's go back to the assignment handout, edit the program file so that it does what it's supposed to do. Okay, we'll do that later. Once you've gotten each part to run, blah, blah, blah. Okay, we don't need to do this submission, so we'll skip over that. So problem 1, collect newspaper Karel.py. So it says our first task is to solve a simple story problem in Karel's world. Suppose that Karel has settled into its house, which is the square area in the center of figure 1. So this box here is the house. During this time, you might correctly surmise that Karel is sheltering in place because Karel is observing good COVID protocol. She is at home. And so Karel starts off in the northwest corner of its house, which is here. The problem you need to solve is to get Karel to collect the newspaper. The newspaper, like all objects in Karel's world, is represented by a beeper. Karel needs to pick up the newspaper located outside the doorway and return to its initial position. So Karel needs to walk over here, pick up the newspaper, and then walk back there. The exercise is simple and is meant to help you get started programming with Karel. You can assume that every part of the world looks like it does in the diagram. The house is the same, everything is the same. Okay, cool. So notice I didn't read all the words. Please don't worry about reading this. You can always read this on your own time, but it's really not necessary. So it says all we have to do is write the sequence of commands necessary to have Karel, 1, move to the newspaper, 2, pick it up, and 3, return to its starting point. Although the program does not have many lines of code, it is still worth getting some practice with decomposition. In your solution, include a function for each of the 3 steps shown in the outline above. Your program should run successfully in the following world: collect newspaper Karel.w, which is the default world. Okay, so what we're gonna do is let's go back to our PyCharm and let's get everything set up. So we did this template.py for a reason. So I am going to just come here, and if you're doing PyCharm, you can come here and you can click on copy. And then I can type Command V, which if you're on a Windows would be Control V, and I'm gonna call this my file name. So if you are not using PyCharm, of course, you can just copy the template.py, paste it a normal way, and just edit your file name accordingly. So I'm gonna click OK, and now it's opened my file. So they told me the world that I needed to use. So let me come here. I'm going to copy. And then I'm going to change this world that we were using before to be the world that we need for this program. And so now let's just do a nice little test. We're just gonna run this and make sure that the world comes up the way that we think it should. So I click on run, click on connect newspaper Karel, and cool. Looks like Karel does look like the picture. And if we click run program, now it does nothing because we haven't implemented anything yet. So far, so good. Okay, so the next thing that it told us to do was it did tell us to get practice with decomposition. It says include a function for each of the 3 steps shown in the outline above. Okay, so the way that we do this is pretty straightforward. I'm gonna write simple functions, move _to _newspaper. And then I'm gonna put my parentheses, because when you're calling a function, you always have to have the parentheses, because sometimes you need to pass in what we call arguments to functions. In this particular case, we don't need anything, so the parentheses are just gonna be open, close. Notice that this is underlined in red. It's saying unresolved reference, move to newspaper, because we never wrote a function called move to newspaper, but that's okay, we'll do it later. So this is a common tactic in coding. You just say, okay, I'm gonna assume that I have some function that does this. I'm gonna call the function, and then later on, I'll go back and I'll fill it in. So we had move to newspaper, we have collect newspaper, and we have what, let's say return to start, right? So we have these three functions. This is what they told us to do: move to newspaper, pick it up, return to starting point. Cool. Okay. So that's what we have. So now we say, okay, I've done my functions. Now, how do I actually do this, right? So the first thing that we need to do is to actually define a function. So I'm going to go ahead and just define all of these three functions so that way our program will at least run. So the way that we define a function is just the same as this. So we have def space main, blah, blah, blah. So I'm going to copy this because I don't feel like typing, and I'm just going to paste this. Oh, that did not work. Let's try that again. Copy, paste. Okay, cool. So that worked. So I'm going to rename this. So I'm going to copy this from here and I'm going to paste this here. Now you have to make sure that these names match exactly. If they do not match, things will not work. They will not work. They will not work. And I should have just pasted that again while I was pasting things, but I didn't. So I'm just going to get this ready. Okay. So now I have all my three. Oh, sorry. To change the name of this, change the name of this, change the name of this, change the name of this. So I'm going to pause here just to give you a little bit of time to kind of catch up. But pretty much all I've done so far is to write these three functions in my main function, and I've defined my three functions. So if you're paying attention, you'll notice that there's still some like red underlined things. This format doesn't fully work, so we need to put something in these functions. Otherwise, it will complain. So there's a keyword in Python which is called pass, and pretty much what pass does is it just does nothing, but we can put it here so that we have some function that exists. So when I try to run my program, it's not going to say, oh, you didn't define this function, your function is empty, you can't have empty functions. So we just write pass, which is pretty much an unimplemented function. There are other uses of pass, but in this case, we're just using it so that it thinks that we've implemented our functions, even though we haven't. So hopefully everybody's able to follow along so far. So what we're gonna do is we're gonna go ahead and run again, just to make sure. We run program, nothing happens, which is fine because all of our functions just say pass, but at least we know that we don't have any syntax errors or compilation errors. So I haven't really talked about compilation up until now. So Python is what we call an interpreted language. So you don't have a separate step for compiling versus running the program. It pretty much does it like as it goes. But if I had an issue with like an unimplemented function or something like that, I would have had an error when I tried to run the code. So even though it doesn't do anything, I did verify that there are no errors. So at least I know that the structure of my program is good. So that's always a good way to start, just to make sure that you don't have any type of like, oh, this is called move to newspapers with an S or something like that. That's another advantage of using the IDE, which I talked about in my last one, because if you notice here, it's telling you things, right? As we're going along, it's going to tell us, you know, hey, this doesn't exist, this is unresolved. So I don't actually have to run the code to find out what the error is. It's going to already tell me that. So let's go ahead and run this again so that we can see the picture. So we have to move to the newspaper. So the newspaper is over here. So let's see, how would we do that, right? So we said, okay, well, I could, do this. I say, okay, well, I need to walk a step. I need to walk another step. I need to turn right. I need to walk a step. I need to turn left and then move forward. Now, if you're not able to follow along, let me try to move my mouse. So let's do this one by one, right? We're literally going to just do this one by one, and then you guys can see kind of what happens, right? So I think you can probably follow if we walk 2 steps, right? And then we turn right. So let's just do that and see what happens, right? So the way that we walked a step was move. So that's 1 step. We type move again. That's 2 steps. And then we said, I want to turn right. But now I'm like, oh, wait a minute. This is underlined in red. Because guess what? Karel doesn't know how to turn right. So how can we resolve that? Well, the way that we can resolve that is we can define another function, def turn right. Now, if you were standing here and you wanted to turn right, but the only thing you know how to do is turn left, how would you do that? I'm guessing you would say, okay, well, I'll just turn the other way. I can turn left multiple times. So the way that we can turn right is by turning left, and turning left again. And I forgot my semicolon, that's why that is red. So now I've written a turn right function, and now this is not red. So we did that. So let's just confirm if we were able to actually do this successfully. So let's run program. We move, we're going, turning left. Okay, cool, we turned right, so that's good. So let's close this. So now after this, we said, okay, let's, we need to move again. And we said we needed to turn left. So now let's verify that. Run program. Okay, cool. So far so good, but we're still not at the newspaper. So we're like, okay, we're only one step away, so that shouldn't be too bad. So all I need to do is add another move, right? So now I think my move to newspaper function is probably complete, but let's just run it again just to be on the safe side. Nice. Okay, we've moved to the newspaper, so that's cool. So now we need to collect the newspaper. So let's go back and look at the reference, right? How can we collect the newspaper? Which of these functions seems like it would do what we're trying to do? We have move, that's not it. Turn left, that's not it. Put beeper or pick beeper. Oh, let's pick up a beeper. Cool, that should work. So my def collect newspaper, I just need to, and again, here we can see that it's auto completing for me. So that's really nice. I can just type tab and it will finish. So I don't actually have to type the whole thing, pick beeper. So I think that's all we need to do. So let's just go ahead and run this to be sure. Run program. Nice. I got the newspaper. Okay, so that's really good. So now we only have one more thing to do, which is to return to the start. And I shouldn't have closed that, but I'll just show you guys here. So now we're standing here. So how do we get back? So we said, okay, well, first of all, I'm facing to the right, but I need to go left and I can't walk backwards. So what do I need to do? I probably need to turn around and then I need to walk 1, 2, 3 steps. Then I need to turn right, walk a step, and then turn right again. Okay, so let's do this in phases. So I said I need to turn around, which I'll worry about that later. You can see it's red. We won't worry about that later. And then we said we need to walk, how many? 1, 2, 3 steps. Okay, so we're gonna do move, move, move. Okay, so now we're standing here. We need to turn right. We need to move. And let's see, turn right and move. And I think that was it. So now let's just write our turnaround function. So again, we only know how to turn. Now you say, okay, turn around. You could say, okay, I can turn right and turn right again. That would work. But don't forget that our turn right function is turn left 3 times. So if I say that I'm going to turn right twice, that's actually me turning left 6 times. I don't really want to do that because that's 6 steps. I could also just turn left twice, which is only 2 steps. And so we're definitely going to try to make this program faster, and we're going to use the more efficient route, which is turning left 2 times. So we turn left, and I don't notice any more red lines, so I think I'm good. So let's run this and see what happens. Okay, we're back in the right spot, but notice we're facing the wrong way. So that is not the end of the world, but if you actually turned in an assignment like this, you probably would lose points for not refacing Karel in the way that she was originally facing. But we can easily resolve that. All we need to do is just turn right again, and this should be it. Yay, we did it. That wasn't too bad. Hopefully you were able to follow along for the most part. You can definitely go back and, watch again and, kind of, try your own hand at it. I do have the assignment handout in the description box, so you can actually go ahead and try to do the rest of the assignment yourself if you want. I will be doing videos on the rest of the parts of this assignment, so definitely make sure that you come back to check those out as well. So if you enjoyed this video or if you learned something, don't forget to like, subscribe, and share with all your friends, and I'll see you next time. Bye. Pepper, what are you doing? Please be quiet.